Error correction and error detection. We know that in networks, our data is divided into number of small chunks called packets. These packets only travel across source to destination through transmission medium. So we found two kind of errors while transmitting. First one is congestion. So congestion is nothing but when router receives many packets at same time from various sources. Due to this situation, router buffer got filled. So router can't accommodate all the packets at the same time, so it discards some packets. This is known as congestion. We are using lot of flow control mechanisms like stop and wait ARQ, selective repeat ARQ between network devices. Because of these mechanisms, sender receives the discarded packet message. So it will retransmit the packet again. So really it will happen automatically between network devices. So we are not going to discuss much about this topic here. So we are going to discuss second kind of error, that is errors inside the packet. Due to voltage fluctuations or some other reasons like thunderbolt, transmission medium breakages will corrupt single bit or group of bits inside the packet. First one we will see single bit error. So only one bit of the packet got corrupted while receiving at receiver end. This is known as single bit error. So more than one bit got corrupted means we call it as burst error. To handle these kind of errors, we use two kind of mechanism. One is error detection and another one is error correction. First one is error detection. Error detection is nothing but it just find the packet is corrupted or not. If yes, it asks for sender to retransmit the packet again. Understand, it only find the packet is corrupted or not. Even it can't locate the error inside the packet. First error detection method is duplicate data method. It is like our password and retype password fields in online registration forms. When you type different passwords, it rejects both and asks for retype both the passwords. Like that, in our data transmission, we send data packets twice. At the receiver end, it checks for both are equal or not. If yes, it accepts, otherwise it rejects. So practically we are not using this method. For example, we need to transmit 1 million packet means additionally we need to transmit another 1 million packet for verification. So it uses huge bandwidth. So practically we are not using this method. In error detection, the second method is parity bit method. It have two types, one dimensional parity and two dimensional parity. First we go with the one dimensional parity. In this method we additionally add one extra bit to balance the number of ones in the byte. We can set it as even or odd parity. In our example we used even parity. In our example we have two number of ones available in our byte. To maintain even parity, we add 0 as parity bit. Second type is two-dimensional parity. So two-dimensional parity also does the same calculation like adding parity bit horizontally and vertically across each byte. In our example, our first byte have 3 number of ones. To maintain even parity, we add 1 as parity bit. In this parity bit method, we need to send 50% of redundant data along with our original data. So practically this method also not in use due to high bandwidth usage. Third method is checksum method. In this method we use something called checksum. So this method is known as checksum. So fourth method is CRC method. So that is cyclic redundancy check method. So we use some code called cyclic code and add some extra bits called redundancy bits. At the receiver end we check for error detection. So this method totally is known as cyclic redundancy check. In our network devices we are using checksum and CRC methods for error handling. We will discuss one by one in our next videos. In error handling, we have two methods. One is error detection, another one is error correction. So error detection we already seen. The second method is error correction. So error correction is divided into 3 steps. First step is find out the packets which containing errors. So second step is locate the error inside the packet. Third one, correct the error. In our error detection, we just find out the packet which containing errors. It can't locate and correct the errors. So in this method we can locate the error and correct the error. So it takes huge bandwidth for calculation and redundant data. So practically we are not using this method. So example for error correction is Hamming codes. If this video helpful to you or any of my videos helpful to you, Please don't forget to share with your social media contacts. Show your love and support to my channel through like, share and subscribe. It will promote my video so a lot of people get benefited. Thanks for watching once again.